Hi everyone. This video is going to introduce you how to form the equation of the circle. So equation of the circle, we have two form. One is a standard form, the other one is a general form. So first I will show you how to derive the standard form of a circle equation. So first we will have our diagram of a circle where this line is showing the radius of the circle, and this line is actually connecting the center of the circle to the circumference of the circle. Okay, where the center of the circle I represent it by HK, and this length having the radius R, and the circumference of the circle, the point is given as P, which I represent as X, Y. So using the distance formula meaning that we are going to find the length of the CP, which is given by R. So R equals to CP. How do you get the length of the CP? So using the distance formula, we have a square root of X minus H square plus Y minus K square. After we square both sides, we want to eliminate the square root. Squaring both sides, you will have your r squared equals to x minus h squared plus y minus k squared. And this is actually the equation of a circle in the standard form. All right, so we have this equation of the circle. This is a standard form. And this standard form is very useful because from the standard form of the circle equation, we can determine the center of the circle and the radius of the circle very easily. All right, so look at this standard form of the circle equation. To find the center, we are going to take this value, plug this value, and change the sign. If this is a negative h, I'll change the sign into the h, positive h. And this is a negative k, I'll change the sign into the k. All right, this is actually the center of the circle where the x coordinate is a h and the y coordinate is a k. And the r square, this is representing the r square. So taking the square root of the r square, I got my r. R is actually representing the radius. All right, this is very obviously, you can see it from this diagram. Okay, so from here, we can actually derive the general form of the circle equation, which is given as x squared plus y squared plus 2gx plus 2fy plus c equals to 0. And how are we going to get this? Firstly, from the standard form of the equation, we expand it. Expand the equation 1, and we get this. Expand and rearrange it, you will get x squared plus y squared minus 2hx minus 2ky plus h squared plus k squared minus r squared equals to 0. Substituting the negative h as the g, all right, the negative h I substitute as a g, and the negative k substitute with the f, and the h squared plus k squared minus r squared substituted as a c. We'll get this. And I'll call this as the standard general form of the circle equation. All right. So why do I represent the general form in this form? There will be the coefficient of the s is 2g and the coefficient of the 2f. All right, later on you will see, because the g and the f is very useful for us to determine the center and the radius of the circle. All right. If a circle is given in the general forms, the radius and the center of the circle can be determined by completing the square. So from the general form, I can convert back this general form into the standard form by completing the square. Completing the square, first of all, you have to make sure that the coefficient of the x squared and the y squared to be 1 first. Then after that, you collect the terms of containing x together from these two terms, and This two term is actually collecting the y square and the 2fy together, and the constant we always put it at the end. And after that, you start to complete the square, you get this. All right, for the x term, you got this, and for the y term, you got this, and the constant, you just copy through. After that, all the constant that would be a negative g, negative f squared, and c, you will move them to the right-hand side, and you have this. All right, so after you got this statement, you can compare with the standard form. This is a standard form. This is a standard form. All right, compare with the standard form of the circle equation. Actually, you can say that the h equals to negative g, and the k equals to negative f, and the r equals to square root of g squared plus f squared minus c. So here we can conclude that center is actually equivalent to hk. So from here, we say that center, if your circle equation is presented in the general form, you also say that center of the circle is equals to negative g, negative f, which is the coordinate of the center, and the radius is actually equals to square root of g squared plus f squared minus c. All right, so this is a formula. Thus, the general equation of the circle, we can actually memorize this as formula. C equals to negative g, negative f, and r equals to square root of g squared plus f squared minus c. Yeah. Thank you for watching my video.